Hello. In this video, we're going to look at division of polynomials and the remainder and factor theorems that you need to know. Before we begin, we're going to do a little pre-assessment activity, and I tell my students in Math 009 all the time that one of the reasons why we need to understand the process of division with numbers and not just rely on a calculator to do it is because when we have to divide polynomials, it's the same exact process that we use for division with numbers. So let's divide 237 by 7 using long division. What's the divisor, dividend, quotient, and remainder? So when we set this up, the divisor goes on the outside. That's the thing we're dividing by. The number that we are actually dividing is the dividend that goes inside our division symbol. The quotient is the result. How many times can 7 go into 237 without going over? And the remainder is anything that's left over. So if you recall, when we divide and do long division, we break this into pieces. We would say 7 goes into 237. Well, that's a hard multiplication fact to figure out. And so what we would do is we break it into a smaller part and say, okay, well, how many 7s would go into 23? Now, we understand that that's not 23. It's representing 230, but we're going to treat this in the tens place. So 7 times what gives me something close to 23 without going over? That's going to be 3 7s, which gives me 21. Now, if you think about that, that's in the tens place, so that'd be like a 30, which would be like 210. So just keep in mind that we're not trying to lose our place values when we do this. We then subtract to find out what's left over. We have a 2. We bring down the next digit. 7 goes into 27 3 times, which is 21. We subtract. There's nothing else to bring down. So we have a remainder of 6. So our quotient is 33. Our remainder is 6. So we're going to do the same thing. And we can represent this as 33 and 6 sevenths. So we're going to take this same concept and apply it to dividing and using long division to divide polynomials. We're going to take our dividend, 2x to the third minus 11x squared plus 13x plus 15. We're going to divide that by our divisor, which is 2x minus 5. And we're essentially doing the same thing. We're trying to figure out, what do I multiply 2x by to have it match this term 2x to the third? So essentially, we're trying to figure out, we're kind of working backwards to figure out, what do I multiply 2x by to get this factor? That's going to be an x squared, because x squared times 2x squared equals 2x cubed. But we can't just multiply it by only the 2x. We also need to multiply it by the minus 5. So that's going to be minus 5x squared. So in this step, I'm going to write in orange to the side. We did x squared times 2x minus 5. To get this part, we then will subtract this, just like in our division with numbers. We subtract to find out what's left over. The reason why we subtract is because we want the opposite of, when you subtract the same values, you get 0. So 2x cubed minus 2x cubed gives me 0. Then I have negative 11x squared minus negative 5x squared, which is going to leave us with negative 6x squared. I'm going to bring down my next term, plus 13x. From there, we're going to figure out, what do I multiply 2x by to have it match negative 6x squared? So that's going to be, let me get a different color, that's going to be a negative 3x. If I multiply negative 3x times 2x minus 5, what do we get? We get negative 6x squared plus 15x. Remember, we're then going to subtract this whole thing from what we have. So negative 6x squared minus negative 6x squared is 0. 13x minus 15x is negative 2x. Bring down our last digit, or last term in this case, because it's not a digit, it's a polynomial, that's a term. So I'm going to say, what do I multiply times 2x to match negative 2x? That's going to be a negative 1. Okay, so negative 1 times 2x minus 5, that's going to give us negative 2x plus 5. We then subtract, and we end up getting 15 minus 5, which is a 10. So our remainder is 10. We'll write that as a fraction of what our remainder is over our divisor. So that is long division with polynomials. There we go. That's our first example. Let's move on to our next example. We have our dividend. So that's x to the 5th minus 3x to the 4th plus, I'm going to put in a 0 x to the 3rd plus 0x to the 2nd, because notice how there's a gap in between these, plus 12x minus 33. I like to make sure I do it that way so that I can not lose track of any of my terms that I need in my result. So our divisor is x minus 3. So I'm thinking and looking at this and trying to decide, what do I multiply x minus 3 by to get x to the 5th? Well, that's going to be an x to the 4th. X to the 4th times x minus 3, that gives us x to the 5th minus 3x to the 4th. We subtract that, something interesting happens. I end up getting 0, and then negative 3x to the 4th minus negative 3x to the 4th is 0. So I'm left with a 0. I'm left with that 0 and that 0. So we actually didn't need those, but sometimes you do, because I would say times 0 times 0 times 0, which we don't need. So then I'm going to bring down my next terms, which is going to be a 12x minus 33. And I'm going to say, okay, well, x times what gives me 12x? That's going to be times 12. If I do 12 times x minus 3, that gives us 12x minus 36. We're going to subtract that. 12x minus 12x is 0. Negative 33 minus negative 36 is equal to positive 3. So our answer is x to the 4th plus 12. And then our remainder is 3 over x minus 3. Okay, there we go. Let's try another one. I love long division with polynomials. It's very methodical. You're just figuring out, how do I get my divisor to, what do I multiply it by to get it to match my dividend? And that's why I like it. 2x to the 3rd plus 2x squared minus 16x plus 32. That's all being divided by x squared minus 3x plus 4. What do I multiply x squared by to get it to match 2x to the 3rd? Well, that's going to be a 2x. 2x times x squared minus 3x plus 4, which gives us 2x to the 3rd minus 6x squared plus 8x. We're going to subtract this entire thing from each of those terms. 2x to the 3rd minus 2x to the 3rd is 0. 2x to the 2nd minus negative 6x to the 2nd gives us 8x to the 2nd. Then we have negative 16x minus 8x, which is negative 24x. And I'm going to bring down my next term. Then I figure out, what do I got to multiply x squared by to get it to match 8x squared? So all I'm missing is the times 8, so it's going to be a plus 8. not 18, just 8. 8 times x squared minus 3x plus 4 gives us 8x squared minus 24x plus 32. That's beautiful. We will end up with no remainder because when I subtract this, it's matching it exactly. That's just going to be 0. So our answer is 2x, or our quotient is 2x plus 8. Okay. All right. The next part of this is using what's called synthetic division. Now, I like long division and could do that all day long because it's so methodical, but I really like synthetic division because it takes that process from long division and actually shortens it down. So essentially it's going to allow you to do the division without having to write out the whole long division. So synthetic division is a shorthand for long division. It gets the same process done. We only use this when the divisor is in the form x minus c. Okay, it could also be x plus c because x minus negative c is the same thing. Okay, but essentially what it's saying is we can only use synthetic division when the divisor is a binomial. So in the last example we had, where is that? My divisor was a trinomial. I could not use synthetic division on this one. But that one, number 2, we could have totally used synthetic division. So let's look at the process for synthetic division. We're going to use this example we have right here. X to the third minus 13x squared plus 46x minus 49 is being divided by x minus 8. So our C value is 8. The setup, we're going to write the value of C in a box. So I'm going to take 8 and I'm going to put it in a box. We're going to write the coefficients of the dividend to the right of the box. So the coefficients of all of these terms on our dividend, we're going to write to the right of the box. I actually like to write it like this. And I would write a 1 because the x cubed has a coefficient of 1, negative 13, 46, negative 49. Okay, skip a line and draw a horizontal line below the list of coefficients, which is what I essentially did right here with this little upside down box. And then we're going to bring down the leading coefficient from the dividend and write it below. So we take this leading coefficient, bring it down, and that's a 1. Now here's where it gets fun. The division. We multiply the value of C by the number below the line. So 8 times 1 is 8. We write the result in the next column above the line. So 8 times 1 is 8. We write it there. We then add the numbers in the column above the line and write the result below the line. So negative 13 plus 8 is negative 5. And now we repeat. Negative 5 times 8 is negative 40. 46 plus negative 40 is equal to 6. 6 times 8 is 48. Negative 49 plus 48 is negative 1. So remember, you have your coefficients, you bring down your leading coefficient, you multiply, then add. So we multiply these, wrote the result there, and then we added to get this. We then took the negative 5, we multiplied times 8 to get negative 40, and then we added to get 6. So forth and so on. Now here's where we get our result. The last value is your remainder. Okay, so if your last value is a 0, that means there's no remainder. That means it divides perfectly and evenly into our polynomial. But if there is a last digit in that last column under the line, then you have a remainder. And then these are your coefficients for your polynomial, starting with your constant at the far right. So I would have 6, and then this is my x term. So it's going to be negative 5x plus 6, and then this is my x squared term. So I have x squared, and the coefficient on that is a 1. My remainder was a negative 1, so it would be negative 1 over x minus 8. And that is synthetic division. Again, it's described here. The rightmost number below the line is the remainder. The other numbers below the line are the coefficients of the quotient in order by the degree of the term. Okay, notice that the degree of the quotient is 1 less than the degree of the dividend. So if my dividend was a cube to the third power here, notice my quotient has a highest degree of 2. Okay, all right, let's do some synthetic division examples. We have x minus 3, so if I think of this as x minus c, our c is 3. That's going to go in the box. We're then going to write the coefficients of our polynomial there. Now, again, I'm going to write down anything that's missed. I'm going to put in zeros just in case, because you never know when you're going to need that. You never know when you might get a negative result from subtracting them or adding them together. So in this case, it's not going to have one, because if you look at this, this might be exactly the same problem that we did before. Exactly the same problem that we saw before, but I'm still going to write the additional terms inside. So I have 1, negative 3, 0, 0, 12, negative 33. Okay, so bring down my first digit, my leading coefficient. I multiply these together. 3 times 1 is 3. I add these. Negative 3 plus 3 is 0. 0 times 3 is 0. 0 plus 0 is 0. 3 times 0 is 0. 0 plus 0 is 0. 0 times 3 is 0. 12 plus 0 is 12. 3 times 12 is 36. Negative 33 plus 36 is 3. So again, this is my remainder. So I would have 3 over x minus 3. My constant is a 12. And this leading coefficient would be an x to the 4th. You notice that's the exact same result we got for number 2 when we used the long division. So synthetic division does the same process as long division. Honestly, it doesn't matter which one you use if you're just asked to divide. If it says a specific method and asks you to show your steps, then you need to show your steps to match the correct process. But if it just says divide and it gives you 2 polynomials, do which way you like the best. All right, number 5. We have our x minus, we would consider this the same as x minus negative 10. So my c value is actually negative 10. Goes in the box. Put the upside down L, or I'm going to write my coefficients. Now look at something very carefully. This is not written in order, so you would want to rewrite it in order. 3x squared plus, 3x cubed plus 25x squared minus 48x plus 20. You want it to be in the correct descending order. So then I write my coefficients from my dividend. 3, negative, I almost messed up right there and then. So be very, very careful. 25, negative 48 plus 20. I don't need the positive sign. I can just write 20. Okay, bring down my leading coefficient. We have a 3. All right, negative 10 times 3 is negative 30. 25 plus negative 30 is negative 5. Negative 10 times negative 5 is positive 50. Negative 48 plus 50 equals positive 2. Negative 10 times 2 is negative 20. 20 plus negative 20 is 0. So we have a 0 remainder, so no remainder. So our result for this one would be 3x squared minus 5x plus 2, and that is our quotient. Okay, so the remainder theorem states if a polynomial f of x is divided by x minus c, then the remainder is f of c. Note that the value of f of c is the same as the remainder we get from dividing f of x by x minus c. So let's use the remainder theorem to evaluate f of -1. So on the side here, I'm going to use and evaluate f of -1. I could substitute in -1 into each of these and solve. Let's see what we get. Okay, so I substituted in -1 into my function and solved to get f of -1 equals -1. Now, I'm going to use the remainder theorem to evaluate it just by dividing the polynomial by my x minus c. So in this case, my c is -1, so I would have x minus -1. Okay, so my value in the outside, I'm going to use synthetic division. I'm going to have a -1 in my box. And my coefficients are 5, 0, -3, 0, 0, 2, 0, -1. Remember, anytime I jump over, I need to make sure I account for that value by replacing it with a 0. So this is my x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and my constant. Okay, so then I bring down my leading coefficient. -1 times 5 is -5. 0 plus -5 is -5. -1 times -5 is equal to +5, and -3 plus 5 is equal to 2. -1 times 2 is equal to -2. 0 plus -2 is equal to -2. Notice how I need those zeros there. I couldn't just skip over them. -1 times -2 is equal to +2. 0 plus 2 is equal to 2. -1 times 2 is -2. 2 minus 2 is equal to 0. -1 times 0 is 0. 0 plus 0 is 0. -1 times 0 is equal to 0. -1 plus 0 is -1. Remember, this is my remainder. Notice that my f of -1 equals my remainder I got when I divided. Okay, so again, I can, on this next one, instead of evaluating f of 2, I could just divide the polynomial by 2 using synthetic division, find out what my remainder is, and that will be equal to f of 2. So let's do it. 1, -4, 5, 3. Bring down my leading coefficient. 1, 2 times 1 is 2. -4 plus 2 is -2. 2 times -2 is -4. 5 plus -4 is equal to 1. 1 times 2, or 2 times 1, is equal to 2. 3 plus 2 is equal to 5. I don't know why I wrote my circle over here. My circle should be right here. This 5 is my remainder, and it is equal to f of 2. Okay. And then we have our factor theorem. Let f of x be a polynomial. If f of c equals 0, then x minus c is a factor of x. If x minus c is a factor of f, then f of c equals 0. So we can use this fact to determine if something is a factor and can divide evenly into a polynomial. This is super helpful because later in a later section, we're going to be looking at zeros of polynomials. And if you can find a factor, you can then divide and then factor it out even more. So this is a super important theorem that we need to know. So we're going to use this factor theorem to determine if x plus 4 is a factor of f of x equals 6x to the 3rd plus 11 x to the 2nd minus 60x minus 32. Now remember, we're looking for something in the form of x minus c. So if I have x plus 4, that's the same thing as x minus -4. So my c value is actually a -4. So I'm going to use synthetic division to divide. And what I'm looking for is my remainder 0? Because remember, if f of c equals 0, then it is a factor, okay? Okay, and vice versa. If it's factor, then we have no remainder. So I'm going to use synthetic division to divide. We have a coefficient of 6 on the x cubed, 11 on the x squared, and negative 60 on the x, and a negative 32. Bring down my leading coefficient. Negative 4 times 6 is negative 24. 11 plus negative 24 is negative 13. Negative 4 times negative 13 is equal to 52. Negative 60 plus 52 is negative 8. Negative 4 times negative 8 is positive 32. Negative 32 plus 32 equals 0. My remainder is 0. So therefore, x plus 4 is a factor. It divides evenly into our polynomial. All right, factor 2x to the third minus 3x squared minus 11x plus 6 equals 0, given that x minus 3 is a factor. So they're telling us it's a factor. That means we can divide it evenly, and then we'll be able to factor all the way down. Okay, so we know that x minus 3 is a factor, so that means 3 will divide evenly into this. So I'm going to divide my polynomial using synthetic division. 2, negative 3, negative 11, 6. Bring down my leading coefficient. I'm going to pause while I do this, which means that I can rewrite this polynomial as x minus 3 times 2x squared plus 3x minus 2 equals 0. Now I can factor this by grouping. Is that AC method? 2 times negative 2 is equal to negative 4. A times C gives me negative 4. Write out the factors of negative 4. That would give you a positive 3. When it comes down to it and we factor this, we end up getting that this factors to x plus 2 to x minus 1. So I have x minus 3 times x plus 2 times 2x minus 1 equals 0. So then I can then solve for each of my values that make this true. So I take each of my factors and set equal to 0. We've seen that several times, so I'm just going to go ahead and tell you what the answer is. We end up with the zeros. X equals 3, x equals negative 2, and x equals 1/2. The last thing we're going to do, and we only have 2 minutes to do it, is we're going to write a polynomial of degree 3, so its highest degree is 3, that has zeros 2, that have multiplicity 2, and negative 5. So we have a polynomial function of x. We know that we have a 0 that's 2, so we would write x minus 2, and it has a multiplicity of 2, so that would be squared. And then we would multiply that times x plus 5, because if I have x minus c and I have x minus negative 5, that's my c, that's the same thing as x plus 5. Now I can multiply this out. So I square my binomial, x minus 2 squared is equal to x squared minus 4x plus 4 times x plus 5. I'm going to distribute this out. And we end up getting the polynomial x to the third plus 5x squared minus 4x squared minus 20x plus 4x plus 20. And we can combine like terms. So we end up getting p of x equals x to the third plus x squared minus 16x plus 20. And that's all we need for this section. Thank you.